In this lesson, we are going to go through analog output. Okay, so these are the contents that we're going to go through. Analog output using analog write, and we are going to introduce you to pulse width modulation. Then we are going to talk about, we're going to do the LED dimmer. Okay, how to dim a LED using the analog output. Then after that, we'll talk about color code, and we'll create a color of the day project. Analog output. So analog write is the function that we use to write a different value to control the brightness of the LED. So this is just how we want to control some of devices. So an example will be the LED. If we want to dim the LED, instead of full brightness, we can actually adjust how bright we want it. We can use actually the analog write function. Okay, so pulse width modulation, how does it actually work? Is if you look at this range of these charts, 0 volt, 5 volt. So even is 0% duty cycle, one duty cycle, which one green bar to the other green bar is 2 milliseconds. So 0 volt to 5 volt. So it can't actually output a range like 2 volt, 3 volt. It can't actually do that for the Arduino. So this hardware actually don't do that. So what it can do is that we can adjust the amount of duty cycle that it does. So if you look at this 0% duty cycle, that means it's outputting 0 volt. So it should be 0 volt throughout the duty cycle. And if it's 5 volt, it will be 100% duty cycle. So throughout the whole cycle is 100%. It is 5 volt, and you will realize that analog write, the maximum is 255. Analog write minimum is 0 to 255. That's the range. Okay, so if it's a 50% duty cycle, that means how do they actually create the effect that it is like 2.5 volt? Basically, it outputs for half the duty cycle. So I give it half the cycle, 5 volt, the other half cycle is 0 volt. It will create the effect that is actually like 2.5 volt, but actually it's not. It's just output 50% for the duty cycle. So similarly, for 25% duty cycle is 25% of the duty cycle is 5 volt, the rest of it is 0 volt, and 75% is 75% of the cycle is 5 volt, and the remaining 25% is 0 volt. So throughout, so like this, it creates that effect of how much output you are actually giving it. So that is called the pulse width modulation. Okay, so next, Arduino, the pins that we use for the analog write function, you can identify them by the dot symbols on the Arduino. So those with dots are 3, 5, 6, 9, 10. Okay, lesser than 1 pin lesser than the Arduino. Okay, so it's just a circuit design that we only have 5 of these pins for analog writing. So later when you are doing the writing, the output, okay, for analog you need to use 3, 5, 6, 9, 10, either one of it. Okay, so first thing is just like what I told you, voltage 0 to 5 volt is 0 to 255 for writing, 255 is 5 volt. 1023 for reading is 5 volt, just like what we covered previously. 1023 is 5 volt for reading, but for now is writing is 0 to 255, 5 volt. So how do you convert from reading to writing? So whatever you read 1023, how do you convert it to 255? So you will take 1023 divide by 255, and actually it will integer it, so it will actually be 4, divide by 4. Okay, so you know that 1023 divide by 4, you will get 255.75. But if you do a floor division for this let's say idle, so I can say 1023 divide by 4, you get 255. Okay, so this is how you can do that division. Okay, so conversion. okay, conversion. So let's say, let me just do this again. Command N. Oops, I think my camera is off again. Okay. Okay, never mind. Later I'll do this. So this idle. Okay. So let's go back to this. Okay. This and this. Okay. So let's say 15614. How do we convert the reading 614 to 153? Okay, from reading, whatever you read, convert it to a range for the writing. You can take 614. Actually it's float division. Is basically when you divide that time, if it's in integer, it will auto be an integer. So divide by 4. Okay, divide by 4, you get 153. So that is how they actually do the division. So one easy way to convert is to divide by 4. The another way is to map the value of the reading to 0 to 255. That is how we can actually do this. Okay, next. So what we are going to do for this, we are going to convert the maximum 0 to 1023 for this reading, and then we are going to convert it, and then we will output to this LED. Okay, so previously we were doing the blinking of this LED using this potentiometer, but now what we're going to do is we're just going to dim this. So let's head over to Tinkercad, and we are going to start with potentiometer. Okay, then this to 5 volt. This to the ground. Okay, done. Then this portion ground. Oops. This to the ground. This to 5 volt. Red. This we'll go to A0. Okay, then next we are going to have our LED resistor. Here should be 330 ohm. 330. Then we have this to pin 3. Now take note, when you use Arduino, the symbols are different. The symbol is a tilde symbol for PWM, but for the SSTuino we use a dot. Okay, just differences, slight differences. Okay, so this is set up. This should be 10k ohm for the potentiometer. Next, once this is done, we go to code. Okay, and next we will delete away these blocks. Okay, I'm just going to delete all of them, and then we can put in this. So we'll read, divide by 4, and then set to pin 3. So set pin 3, set pin 3. Oops, not this. Set pin 3 to division. So this is the right block. Reading input, read analog pin A0, which was the oops, I'm just going to try and put it here. Yeah. So the A0, we're putting it into A0. So A0 divided by 4, and then we will analog write to pin 3. We are going to start simulation. Okay, so now it's flat, nothing. Then when we turn it to the other end, it is the brightest, and then when we turn it down, it actually dims the light. Okay, so this is the first setup. Okay, so this is done. Next, we are going to work on our this hardware. So I have already done this up. Okay, so okay, so this is how it looks like. I haven't write the code in. So same thing, is the same exact setup as what was done on Tinkercad. I'm going to just have to plug in the power. Okay. Okay, so I'm going to open up Arduino. Okay, so first thing is we will need to declare pin mode. Okay, so you can either same thing, if you want to, you should go to blocks plus text. You can actually get these, and then after that you can just follow copy and paste it with some modification like removing the delay. But I'm going to just type it out. Just type it out so you can all see. So pin mode 3 is actually we don't need this pin mode. We don't need to declare anything for this portion here already. Okay, so we will just leave it as like this. What we need to do is we just need to say analog write 3, analog read is 0 divided by 4 bracket. Okay, I think yep, like this will do, because we actually don't need to declare for analog writing, analog reading. We actually don't need to. So I'm going to just try this out. So like this, I'm going to just upload this, cancel, let's just upload. Let's see. Okay, oops, I forgot to put a semicolon, and let's just make sure everything is done properly. Port is not set. USB modem 101, and then let's try upload again. Escape. Okay, we have successfully flashed in the code to the board. So now if I turn this potentiometer, okay, I'm going to just turn it from here. So when I turn this, you can see that actually the LED will dim, and after that, as I turn this, it will become brighter. Okay, so when I dim this, okay, you can see that actually it slowly dim it. So I can actually control this via the potentiometer. So that is the first part of this analog writing. So I'm going to go back to this. Okay, so that is the LED dimmer. Next, we want to share about this color picker. So color picker, how do we define colors in the on computers? So color picker, let's just click on this link, color picker. So colors can be explained, express using these various ways. You can use RGB, which is red, green, and blue. Composition of red, green, and blue. So if it's white color, let's say it's white color. Okay, you can see that it is maximum red, green, and blue full. Okay, full maximum 255, 255, 255 mixed together, it gives you the white color. This is how digital screens, computer screens, they use RGB. So for CMYK, cyan, magenta, yellow key, they actually use this is by color. So the different mixture colors they will create for this is for printing. Okay, for printing. And for some websites, we will use the hexadecimal. So these are different ways that we can express color. So from here, you can actually see that colors. Let's just maybe try and click on white color. Okay. Okay, and maybe I'll change this to red color. If I go to the other end, okay, red color. Okay, 25. Okay, so if it's all the way to the other end is 25500. So red. So the red color, a little bit of green, a little bit of blue. So from here, for SST, the colors are of our SST blue, red, and gray is expressed here. For our blue is red 0, green 120, B201. Okay, so you can actually try and create the colors using the RGB LED. Now in Tinkercad, the RGB LED is like these: red, then negative, this is ground to the ground, then blue, green. But in a real RGB LED, the longest leg is a negative, and then after that red, green, and blue. So this is how it is in the real world. So there is some differences between the Tinkercad and the real RGB LED. So this is a simple RGB LED setup. You can try and do this. We can try and do this in this circuit. I'm going to maybe try and do this. I'm going to delete this. Okay, the easiest way is to choose this, and delete, all gone. Then after that, I take this out again. Okay, and I'm going to just take out the RGB. Okay, from the RGB, we'll just put here red, ground, this is cathode, blue, green. So how to set up this RGB LED? I actually like to do it here. Then after that, I like to have the resistors. Okay, now in this circuit, you don't you need to have three resistors. You can't have one resistor to this ground. So instead, we will split it to 3. Okay, because there is 3 power source. Okay, 3 different power source. So you need to have 3. Okay, or else you will blow your you may blow your LED bulb. So 330 ohm. Okay, then we will have 1, 2, 3. Okay, so like this is how I would do this, and then after that I have 1 to the ground. Okay, ground, black, and the rest we will go on connect to the ground. Then we have the other 3. Now you should use the pins here. So 3, 5, 6, 9, 10. So I'll probably use 3, 5, 6. Okay, so 3, 5, 6 6. I'm going to have 1. So you will want to I'll just do it these are 3. So this is red, blue, 5, and 6. So this will be green. Okay, so the different colors. Okay, done. So code. Okay, in the code I'm just going to do blocks, and I'm going to just delete this. Then no, I think it's okay. Maybe I'll just yeah, I think I'll just delete this first. Then output RGB LED pin. Now this one is red, green, and blue. So 3 red, green, and blue. So 3, 6, 5 to color red. So let's start simulation first. And it's red color. If I choose a different color from here, you can click. Maybe I choose orange. And okay, yeah, it's about the same color. Okay, so maybe you can do and try a different color, maybe this color, and start simulation. Red, green, and blue. Doesn't seem to be very similar, so I'm going to just choose a different color first. Blue. Start simulation. I think it's okay, close enough. Maybe green. Okay. So it should be correct. Okay, 3, 6, 5. So this is actually red, green, blue. So this is how they actually express this for this block. But this block is kind of useless. It's not very useful for this circuit that we want to do. So so you can't really program much with these because you can't really change the values for this. You need to manually go and change the color. So I don't really use this. We are going to try and do this instead. One button to actually toggle the LED. So we will actually do this, and after that we'll do on the hardware. So start. So one button, and I'm going to just add in the button here. Okay, and next. So button to 7, and we are going to do it like this. Okay, 7. This to 7. I'm going to change the color to maybe brown, and I'm going to have a 10K resistor. Okay, so it should be here. I think it's here. Okay, so it's a pull up resistor. Okay, so I think it's a pull up resistor, and we'll put another one to ground. This one is 10K. Then we have one to the ground. Okay, black. So that, okay, it's a different setup, but never mind, you can follow this. Okay, so when digital pin 7 is pressed, okay, if digital pin 7 is pressed, that means it drops to 0, low, and previously the button was high. Okay, previously you were not pressing it. So this is just creating a variable to remember the state. Okay, so that it remembers when you press it and when you release it. So this was done previously. So previously you didn't press the button, and you are now pressing the button. Then we'll say that you have pressed the button. So set button state to 0. Okay, so that is what this is for. We are going to do this slowly. Code. Then we will just put in this if else statement. If else, if, and then after that we'll need this. Then we'll have equal. Okay, so we are going to have this. So if analog read digital read, we're going to do digital read digital pin 7. Okay, 7 equal to 0. That means you have pressed it. Okay, and previously you were not pressing it, so we need to create a variable to remember the button state. Button, and button equal to equal to 1. Yeah, button equal 1. So button equal to 1. So if it is so, then set button to 0. Okay, good. Or else you let go. Okay, once you let go of the button, okay, we will set it back to 1. Okay. Okay, so oh yeah, we have another one. If you let go, and then we will set it. Okay, if you let go of the button, okay, if, and set to 1. So if you are thinking if, so I'm going to just copy, duplicate this, and I'm going to plonk it here. So you are thinking where did we do this portion of the circuit? It's actually done in reading and input. You can actually see this in the button state. Okay, we actually did this button state. You can actually look at these circuits. Okay, so here we actually have these. We can just click back to here, and you can see in the code Arduino 1. Okay, this is what was done previously on the button state. Okay, so maybe if you can't remember, you can actually revisit this. But okay, so this is done, and then we will need to say set pin. For this one we will 365. Okay, 365 to set these different pins. Okay, so we are going to say set pin 365 to random. Okay, pick random 0 to 255. So because that is the maximum value for, so it will be a random color generator. So we're going to do this, duplicate 3, 6, and 5. Okay, 3, 6, and 5 to the RGB for the colors. Okay, so done. So when we start this circuit now, and we press the button, hold on, oops, something is wrong. 365, when we press the button, read digit pin 7. Oops, I know why, because we have a missing 5 volt here. We need to have a 5 volt cable to from here to 5 volt. So I'm going to just change this to red. Okay, so now it should work. Okay, so let's start simulation. Okay, and press button, it changes to a random color. When press again, it changes to another random color. Press again, it changes to another color. So when we press, it changes to whatever color we want. Okay, a random color. It just give you a random color of the day. So if you want to further build on this, you can actually expand this out with part 2 by adding on to this portion here to have a new variable. You need to have a variable red, green, and blue, and then you pick random. So you actually replace this portion here to a new variable, and then you just say set this variable to this, and then you set the pin to this, and then after that you will actually be able to print this to the serial monitor. Okay, so that is about part 2. Okay, so that is if you want to do the part 2. We are going to try and do this on the real board now. So I'm going to go back to the board, unplug power. Okay. Okay, so next will be just a button and the RGB LED. So button. Okay, first thing I'll do is the button. So this is the button, and just make sure it's in. Okay, good. Then we need a 10k ohm resistor. So make sure you get a 10k ohm, which is not double orange. It's the one that is has the brown, red, black, brown. We're going to plug this into here, positive, and next we will have these two positive. Okay, so this will be to 5 volt. Okay, so hold on. Going to adjust the zoom again. I think too much. 1.5 will be good. Okay, so like this, 5 volt. Let me just go back to here, check this. Okay, so correct. I'm gonna just continue on this. So here 7, pin 7. I'm gonna plug this to pin 7. Then okay, this is done. We will have another one cable to just make sure we plug this to the ground. Then we have one of these. to the ground. Okay, so the button is set up properly. Next, we have the RGB LED. So take note of the legs of the RGB LED. So you can see the long leg. So you can see this should be red, ground, green, and blue. Different in Tinkercad. Different from Tinkercad. So we just going to plug this RGB LED. Each one leg. I like to plug it here because of the resistor. So it's better that I plug it here. Then I have I need to have 330 ohm. Okay, 330 ohm. Okay, one of these. To the ground. Then we have 2 more. Okay, so 3 resistors, and then we have next we have 3 cables to the 3. We'll just pull these to here. So 1, 2, 3, 3. So this is for 3. Then this is for green. Green will be 5 instead. For this round is 5 and 6. So 5. Okay, and then we have another last one. 2. 6. Okay, like this. It should be done. Just make sure that you can see clearly. Just on the lights. Okay, so it's plugged in to 3, 5, 6. Okay, and 7 for the button. Okay, done. Now I'm going to just plug this in. I'm going to next. We have to code this. I'm going to just open this up. Go to blocks plus text. Okay, this is already done properly for us, but later we will need to modify it lah. So I'm going to just copy this. Okay, copy and paste this here. So that we have a declaration of the button variable. Then we have this delay. This is not needed. Delete. Okay. So if digital read 7 equal 1, okay, blah blah blah. We are going to just okay, I think we should be good to go. Random. Okay, good. I think should be okay. Escape. Let me just try. Okay, so done. So I'm going to just off the light already. No need for the light. Then try and press the button and see what happens. Okay, some things are not working out. Check. Okay, I know why. It's not connected to the ground. We'll connect it to the ground now. Okay. Okay, still not working. Okay, this shouldn't be here, this should be here. Go to ground. Okay, done. So when press, okay, it will actually change the color. Okay, it changes the color to so when I press, changes to a different color. Okay, then I press again, it changes. Press again, it changes. Press, change. Okay, so let me just adjust some things. Let's see whether we can get a better color. Okay, never mind. Just maybe do a focusing. Okay. So this is how we can do a random color for the. Well, maybe I can just tilt this a bit so that, okay, maybe not working. Also good. Maybe I'll not tilt it then. Okay. So anyway, this works. Okay. So it can actually changes the color to a different color every time I press this. Okay. So I just so that's the end of this lesson. Thank you.